Hello, I'm Chris. Welcome to our channel on manufacturing information. Today, we'll explore several tips for reducing costs, aimed at helping engineers like you keep CNC machining expenses to a minimum. But before we dive into the tips, let's quickly examine the factors that impact the cost of CNC machined parts. The first is machining time and model complexity. Remember, the more complex your part's geometry, the longer it takes to machine, and the more it'll cost you. The second is startup costs. These costs relate to CAD preparation and process planning. They are significant for smaller volumes, but can be mitigated with economies of scale. The third is material costs and finishes. The type of material you use and how easily it can be machined can make or break your budget. Stick to simpler designs to keep those costs down. Now that we understand the factors influencing CNC part costs, let's proceed to explore our cost reduction tips. Tip number 1, add a radius in the internal vertical edge. CNC milling tools possess a cylindrical shape, inevitably generating a radius when cutting the edge of a pocket. To mitigate this, introduce a radius of at least 1/3 of the depth of the cavity. The larger the radius, the better. Consistently apply the same radius to all internal edges on the cavity floor. You can specify 0.5 or 1 millimeter, or opt for no radius at all. Tip number 2, limit the depth of cavities. Machining deep cavities significantly impacts the cost of CNC parts. Removing a substantial amount of material is time-consuming, often necessitating special tools. Considering cavity depth, remember that CNC tools have a limited cutting length. Ideally, they perform optimally when cutting cavities with a depth of no more than 4 times their diameter. While it's feasible to cut deeper cavities, doing so escalates machining costs due to the requirement for special tooling or multi-axis CNC systems. To mitigate costs, always restrict the depth of all cavities to 4 times their length. Tip number 3, increase the thickness of thin wall. Thin walls are prone to vibration, deformation, and fractures. Precision machining of such walls is time and cost-intensive. Unless weight is a primary concern, thicker sections are more stable and cost-effective for metal parts. Design walls thicker than 0.8 millimeters, aiming for increased thickness wherever possible. For plastic parts, maintain a minimum wall thickness above 1.5 millimeters to enhance stability and reduce machining expenses. Tip number 4, limit the length of threads. Threads longer than necessary can inflate the cost of CNC parts, often requiring special tooling. To economize, design threads with a maximum length of up to 3 times the hole diameter. For threads in blind holes, it's advisable to add at least half the diameter of unthreaded length at the bottom of the hole to optimize machining efficiency and reduce costs. Tip number 5, consider machinability of the material. If you have options, opt for the one with superior material machinability. Machinability denotes how easily a material can be cut, with higher machinability resulting in faster CNC machining and reduced costs. The machinability of each material hinges on its physical properties. Generally, softer and more ductile metal alloys are easier to machine. Therefore, selecting materials based on their machinability can enhance machining efficiency and minimize expenses. Tip number 6, avoid small features with high aspect ratios. Small features with high width-to-height aspect ratios are prone to vibrations, and therefore difficult to machine accurately. To improve their stiffness, consider adding bracing features or connecting small features to a wall. Also design features with a width-to-height aspect ratio of less than 4. Tip number 7, use engraving text instead of embossing. Incorporating text on the surface of a CNC machine part can elevate costs due to the need for additional and time-consuming machining steps. If text is essential, opt for engraved lettering rather than embossed, as it typically requires less machining time and resources. Alternatively, surface finishing methods like silk screening and painting are generally more cost-effective for adding text to CNC machine parts. Choosing these methods can help mitigate expenses while still achieving the desired text or lettering on the part's surface. Tip number 8, avoid multiple surface finishes. Only request multiple surface finishes when necessary. Surface finishes improve the appearance and resistance to harsh environments of CNC machine parts, but also increase their cost. Tip number 9, take advantage of economies of scale. To leverage economies of scale in CNC machining, consider ordering larger quantities or placing repeat orders. Quantity significantly influences the unit price, largely due to startup costs. In low quantities, these costs represent a significant portion of the overall expense. However, for larger quantities, startup costs are nearly eliminated as they are spread across many parts. Thus, capitalizing on economies of scale can substantially reduce per-unit costs and enhance overall cost efficiency in CNC machining projects. As we wrap up this video, remember that cost reduction in CNC machining is about finding the balance between quality and efficiency. By applying the tips we've discussed, you're not just saving money, but you're also streamlining your production process. Thanks for watching, and until next time, happy machining.